Assalamualaikum students. In my next video of the current electricity horrible question series, here I'm with another question. That question is also very complicated and that can be solved with very easy trick. But as I told you that there are few questions which are really irritating for the students. You people can consider those questions as one of the this question as one of the most tricky question related to Kirchhoff's laws. That is the application area of the Kirchhoff's laws. Okay, the question is there is a current from P to Q, P to R. The resistor network as shown in the figure. Here is a P, here is R, and in that resistor network, let's say these resistors are the resistors. The resistors are not mentioned over here, but let me call it R1, let me call it R2, let me call it R3, and then it is, let's say, R4, then let's say it is R5. These are the five resistors across which different voltages are being dropped. Here 3 volts are being dropped across R1, 6 volts are dropped across R2, no sorry, R4, and then 5 volts are dropped across this one. But there are no voltages dropped or no voltage drop is mentioned across R2 and R5. Now the question is the potential difference between P and Q is 3 volt. What is the potential difference between P and Q? It is mentioned that it is 3 volt, and potential difference between Q and R is 6 volt. It is also shown in the diagram. And P and S is 5 volt. Which row of the table is correct? So let's see what is given in this row. In this row, the given option is the potential difference between Q and S and potential difference between S and R. Now, let's go back to the question, and I explain you that how to handle this type of question with very simple trick, and that is, this question is related to Kirchhoff's laws. And if I say that I have to consider a closed loop, let's say this is your point A, this is your point B, this is your point C, this is your point D, because in between there are two nodes, so these are mentioned. So actually here I have three loops. Loop one is your loop A, B, I mean A, Q, B, C, S, D, and A. And then the loop 2 is actually the inner loop A, Q, S, D, A. And the third loop is your loop 3, which is the right loop, that is Q, B, C, S, Q. So in these loops, actually, if I follow the Kirchhoff's law, I have to select any one of the loop, and then I will follow the next and next and next. So let's say first of all we follow this loop, loop A Q B C S D A. So according to that, if I select this, sum of all the potential differences across this loop must be equal to 0. So when I start from A, I have 3 volts. Then I reach to this point, it is 6 volt. And then there are, let's say, X volts, right? I do not have these voltages. And then I have 5 volts. And then it is coming back to this point. So I was saying that when I say that voltages across all these they are equal to 0, then just select two resistors as load and two resistors as source. So these two, in this loop I have these voltages. So this is 3 volts, this is your 6 volt, this is your X volt, and this is your 5 volt. So I can say that current in all of them is going to be 0. Sorry, potential difference across all of them across the closed loop is going to be 0. So 3 volt with positive sign plus 6 volt with positive sign, I can select these two as the source, and then these two as the load. So it can be minus x minus 5 volt, that can be equal to 0. So if I say that this 3 volts and 6 volt, that would be equals to 9 volt minus x minus 5 volt, that would be equals to 0. So this x would be shifted on the right, so I will get that x is equals to 4 volts. So simply speaking, that the potential difference across this, that is equals to 4 volt. Now if it is 4 volt, then I have to select loop number 2. So in loop number 2, I have 3 volt over here, I have unknown voltages over here, and then I have 5 volt over here. So 3 volt Vx, you can consider it V voltages across this resistor Vx, and then we have 5 volt. Similarly, I have another loop. That loop consists the same resistor again. Then I have this resistor, and then I have calculated this 4 as well. So it is your 6 volt, it is your Vx, and this is your 4 volt. Now if I consider that these uh, two loops are basically the loops, they will give you the identical result. So I can simply manage that. For this loop, 3 is a source, or you can say 5 is a source because that is the largest value. So 5 is the source, and these two are actually the loads. So minus 3 minus Vx, that is equal to 0. So here Vx will give you 2 volts. Similarly, if I want to counter check this, here the 6 volt is the largest one. So 6 volt minus 4 volts minus Vx, that would give me 0 result. So again from here Vx is equal to 2 volts. So I have counted this, that these two values are same, that's why this would give you 2 volts. Now according to that, I will go back to the question. It means across this all, I will rearrange this for you people, because here are 3 volts, 6 volts. If I say that they combinedly give you 9 volts, then the potential difference between these two, that should also be 9. For this to be 9, this is 5 volt and this would be 4 volt, then this value would be 9. So the voltages, sum of all the voltage across this bigger loop, that would be equal to 0. Then I told you that we will select the minor loops then, and for that minor loop, this is 5 volt, this can be considered as the larger voltage in the loop. And then the sum of voltage across this loop, that must be equal to 0. So here I have 3 volts. Here if I will have 2 volts, then 3 plus 2, that will make it 5. And in this one, same goes on. 6 volt is the larger than 4, so I can select 6 as a source. So 6 plus 4 plus 2, if there would be 2 volts across this, then this would be basically 0. Then it means the potential difference across qs, I mean this vertical resistance, they are 2 volts, and cs, that is 4 volt, or sr, sorry, it's sr, I have just mentioned this by myself. So A is the right option. I hope that it is clear to all of you.